Okay, this should be the last video of this section. Find the absolute maximum minimum values of the function on the given interval, then graph the function. Identify the points on the graph where the absolute extrema occur. Graph the function, we're just assuming you're going to do that with some piece of technology, a graphing calculator. If you don't have a graphing calculator, Desmos on the web is a great graphing website. If you want a graphing calculator, don't have one, a used one certainly will work. And if you're not afraid of going into a pawn shop, I've been told that pawn shops are a great place to find used graphing calculators. Anyway, find the absolute maximum and minimum values on the given interval. Always these steps. So 1, find the derivative. That x is not inside the radical. So I've got square root of 3x. And then students will do all sorts of funky things. That square root of 3. That square root of 3 is just a number. That we're going to treat that calculus-wise no differently if it said 5x. The derivative of 5x is 5. The derivative of square root of 3x is the square root of 3. And the derivative of cosine is minus sine. So there's my derivative. 2, critical numbers. Well, all I have to worry about here is the equal to 0 case. So we're going to find the critical number. So I'm going to set my derivative equal to 0 and solve. Trig equation. Solve for that trig value. And so I've got sine x equals square root of 3 over 2. Then we ask ourselves, on the interval from 0 to pi, and that's important here, only on the interval from 0 to pi, where does sine equal square root of 3 over 2? And on the interval from 0 to pi, sine is square root of 3 over 2 at pi over 3 and 2 pi over 3. And that's all we want. Yes, as we go around and around the unit circle, there are more and more values of where sine is square root of 3 over 2, but we only want it on the interval 0 to pi. So there are my critical numbers. Step 3, evaluate the original function at each critical number. So step 3, and I guess we'll go up here, we want to find at each, I didn't read the whole thing for step 3, evaluate the original function at each critical number found and at each endpoint. So I'm going to take 0 pi, 2 pi over 3, and 2 pi over 3 and plug it into the original function. So f of 0 is going to be square root of 3 times 0 plus 2 times cosine of 0. That's going to be 0 plus 2 times 1 for 2. F of pi over 3. So square root of 3 times pi over 3 plus 2 cosine pi over 3. And so that's going to be square root of 3 pi over 3 plus 2 times 1/2, which is square root of 3 pi over 3 plus 1, which is approximately equal to, curly equal sign for approximately equal to, that is approximately equal to approximately equal to 9.44. Keep going, f of 2 pi over 3. So that's going to be square root of 3 times 2 pi over 3 plus 2 times cosine of 2 pi over 3. And that's going to be 2 square root of 3 pi over 3 plus 2 times negative 1/2 be 2 square root of 3 pi over 3 minus 1, which is approximately equal to, oh, my first answer is wrong. I just saw that I typed it wrong. So let's get, I hit a wrong decimal. This is not 9.44. I just saw that I typed something wrong here. This is 2.81, roughly. And so this one here, 2 square root of 3 pi divided by 3 minus 1. And if I type that all right, that comes out to be roughly 2.63. And then lastly, f of pi, the endpoint there. And so that's going to be square root of 3 pi plus 2 times cosine of pi, which would be square root of 3 pi plus 2 times negative 1. So square root of 3 pi minus 2, and approximately equal to 3.44. Now, I put the decimals there only to help us better choose our final answers. So down below, we need to now identify our absolute max and mins. Our absolute maximum is the biggest number I see here, which is right there, absolute max. The biggest of the values I have there, which turned out to be roughly 3.44. Now, what I'm going to write on my answer line is not 3.44, but square root of 3 pi minus 2. Come test time, and if we have quizzes, you write the decimal there, you are not getting full credit. You are never going to get full credit for decimal approximations, because part of calculus is finding things exactly. There's the exact answer. So the maximum is square root of 3 pi minus 2, and that occurred at pi. The absolute minimum is the smallest of the numbers there, which is that guy up there. And so the absolute minimum is 2, and that occurred at 0. So in this particular case, the absolute extremes did not occur at the critical numbers, and that's just the way this problem is. Now, we can check this, and we can absolutely check these by looking at a picture. And so, let's go to y equals, clear that, put the original function in there. So, square root of 3. Square root of 3. In this, make sure you're using your calculator correctly. So I have to end that square root, x plus 2 cosine of x in the parentheses. Now, I'm not going to just hit zoom 6 here, because I have some really good information about this function. First of all, we were graphing on 0 to pi. So I'm going to go a little bit further than 0 to pi. I'm going to start at negative pi divided by 3. And I'm still having trouble getting that. There we go. Pi divided by 3. I picked negative pi divided by 3 because one of my critical numbers there, and I'm just going to count by that. And then it said go to pi. So again, I'm going to go a little bit further. Pi plus pi over 3 is 4 pi divided by 3. So I went just a little bit further than the 0 to pi. It said 0 to pi. I just went a little bit further. And then I'm going to count by pi divided by 3, because both of my critical numbers were at multiples of pi over 3. And so by setting up my calculator to count by pi over 3, I can really look at the picture. Now, as far as my y values go, the biggest number I had was 3.44. The smallest number I had was 2. So my y values, just so I can see in axes, I'm going to go from -1 to 4. Because the smallest value I had was 2. To see the axes, I just went to -1. Then the largest value I had was approximately 3.44. So I'm going to go to 4, and I'll count that off for once. So I didn't just press Zoom 6. I really thought about it. Then it went a little bit bigger than the interval they told me, which is 0 to pi, and a little bit bigger than the y values that I found. And now graph. And there's my graph coming up. Then I said that there should be the absolute minimum at 0. So I'll do a trace, and I'll hit 0, and it'll go to that problem. And yep, on the interval in question, because remember I just went a little bit further than I needed to go. On the interval in question, that point, 0, 2, and that's what I predicted, it is an absolute minimum. We said there should be an absolute maximum at pi. So doing the trace again, putting in pi, hit enter. Now remember, my graph went a little bit further. I took it a little bit further than I needed to, that it was going to end at pi, and it does end at pi. And at pi, that's my high point. And look at the value there, 3.44, which is what I estimated, 3.44. And so this picture absolutely checked. Now I'm going to zoom in just a little bit on the graph itself. Instead of going all the way down to -1, I'm going to go just to between 2 and 4. And so I just kind of zoomed in on it to show something else here. Let's go to trace, and let's go to pi divided by 3, which is one of my critical numbers. Notice that corresponds to my local maximum, and then it tells me my value there is approximately 2.81, which was my value there. And let's do a trace again and go to 2 pi divided by 3, the other critical number I found. Enter. It goes to my local minimum and says approximately 2.63, which you can see right over there, approximately 2.63. And so my other thing, that these things absolutely check by looking at a picture. Now, all we were really checking here were the absolute max and mins. That's what the answer to the question was, absolute max and min. They absolutely checked. But then what the critical numbers were predicting for us in this particular problem, the critical numbers found our local max, local min, and we got the exact numbers that we want. Now, approximations versus what you will always give me exact answers. You will only get full credit for exact answers, but the approximations just help us understand what these values are a little more precisely. Okay, so this isn't going to turn out to be the last video. The next video will be the last video.